Alright then, we're going to be looking at multiplying and dividing rational expressions. Let's just start with the simplification of a single rational expression, and the idea is that we will factor the numerator and the denominator, and then we will cancel any factors that appear in both the numerator and the denominator. And so let's begin with the example A. If we factor this expression, we can see that there's a common factor of x in the top, leaving me with x squared plus 5x minus 6. And there's a common factor of x in the bottom, and we're left with x squared minus 36. And we'll see that these bracketed expressions also factor. So the top factors to x plus 6x minus 1, and the bottom will factor to x plus 6x minus 6, because it's a difference of squares. And our x plus 6's are common factors in the top and the bottom that cancel, and the x's are common factors, those will cancel, and we're left then with simply x minus 1 over x minus 6. And that's the first one simplified. Now if we want to multiply or divide rational expressions with each other, then we'll have to factor the numerators and denominators in each of the expressions. We will either multiply or divide them. You remember that to divide by a rational, that means that we have to multiply by its reciprocal. So we'll combine them into a single rational expression, and then we can cancel any factors that appear in common to the numerator and the denominator. So let's do a multiplication here. So we're going to have to factor. So in my first expression, the x plus 1 doesn't factor, of course, but the bottom factors to x plus 3 and x minus 1. And in the second expression, the top factors to x plus 3, x minus 2, while the bottom factors to x minus 3, x plus 1. Now if I combine these into a single expression, then my new numerator is x plus 1, x plus 3, x minus 2, and my new denominator is x plus 3, x minus 1, x minus 3, x plus 1. And now let's cancel any common factors. I can see I've got an x plus 1 in the top and the bottom. I've got an x plus 3 in the top and the bottom. And that leaves us, there's nothing else that cancels, so it leaves us then with x minus 2 over the product of x minus 1 and x minus 3. And I suppose that if we were leaving our final answer in a simplified manner, which would have no parentheses, well then perhaps we would multiply out the denominator and be left with x squared minus 4x plus 3. Right, sometimes it's helpful to leave your result in factored form, but whenever you get to the very, very end of a question, the supposition is that you would have simplified, and that means getting rid of all parentheses. Now, division of rational expressions is much the same, and so we'll factor the top and the bottom to start. Now, in the first expression, it's already factored for us. I've already got an x minus 2 times x minus 2 in the bottom. Of course, we don't want to expand that by multiplying it out. That's the opposite of factoring. And we're dividing by, let's factor. That's going to be x minus 4 and x plus 1. And the denominator, a difference of squares, factors to x plus 2, x minus 2. Now, we know that when we divide by a fraction, that means that we should multiply by the reciprocal. And so in our next step then, our first expression is just the same. Maybe I'll just write out that x minus 2 times itself. And now we're multiplying by the reciprocal of the second expression. And now that it's a multiplication, we can combine them into a single expression, but I'm going to do this in a slightly more advanced manner. I can see that I'll end up with 3 factors in the top, and 4 factors in the bottom. Because it's a multiplication, now I'm ready to just cancel even before I multiply. So my x minus 4's will cancel. My x minus 2, one of them will cancel in the bottom with the one in the top. And I'm left then with x plus 2 is my only numerator factor, and I've got x minus 2 multiplying x plus 1 in the bottom. And again, if I wanted to truly simplify, I suppose I could multiply out the bracketed expressions in the denominator, so I've got no parentheses in the final answer, x squared minus x minus 2. And there would be your final simplified expression after the division. And the last example is really just another division problem, although it's been given in another form. You might prefer to rewrite it at the very beginning as the top expression, 4a squared minus 1 over a squared minus 4, is going to be dividing a second expression of 2a plus 1 divided by a plus 2. Alright, now we're ready then to multiply by the reciprocal of the second expression. Whoops, actually not quite yet. I need to factor the first, don't I? The top is a difference of squares. It's 2a plus 1 times 2a minus 1. And the bottom is also a difference of squares, a plus 2 times a minus 2. And then we're going to multiply by the reciprocal of the second expression, which is a plus 2 over 2a plus 1. I've stuck them into parentheses to help me visualize what's going to happen when I multiply out my numerators and multiply out my denominators. And you can see I'll have a new rational expression with all 3 of these factors in the top and all 3 of these factors in the bottom. So rather than write out that extra step, let's just do the cancellation straight away. A factor of 2a plus 1 cancels with a factor of 2a plus 1 on the bottom, and a factor of a plus 2 cancels with a factor of a plus 2. And I'm left then with 2a minus 1 over a minus 2. So you'll notice that I couldn't cancel factors when they were on opposite sides of the fraction, and if it was a division. As soon as it's a multiplication, now I can cancel on the top and the bottom without actually combining them into a single rational expression if I wish. I just want to point out that one terrible mistake that you could make is to think that we could cancel the a's on the top and the bottom here. You cannot. The only things that you can cancel on the top and the bottom are factors of the top and the same factors on the bottom. This a is not a factor of the top because it is not multiplying everything in the top. It's multiplying only the 2. If I had had an a in this expression, and an a in this expression, and an a in this expression, and an a in this expression, then I could have factored out a common factor of a from both terms in the top, and I could have factored out a common factor of a from all of the terms in the bottom. Only then would my a's cancel. And so if I have an a in every term, sure, I can factor out that a and then cancel. But if I've got an a in some terms but not in others, you cannot cancel them. So be careful that you do not make that critical mistake. And that's how to multiply and divide rational expressions.